Thank you everyone for your time today in viewing this webinar. We hope it is informative and educational in terms of what REXA offers out there in the water and wastewater industry for helping improve filter control via the use of our product. The agenda for this webinar today is listed here on this slide. We are going to talk, as I mentioned, about the improvements that REXA can offer via retrofits or new project construction on a filter effluent or backwash valve. The discussion will first focus on a case study from the city of Worcester, Massachusetts. It will then turn to a second case study from the city of Elgin in Illinois. We will then point out a couple of other miscellaneous installations and work that REXA has done over the years, and then close with an overview of what we offer for this type of service. My name is Eric Seda. I am the Water and Wastewater Industry Manager for REXA, and my full contact information is listed here on the slide. It will also be given out later on at the end of this presentation for any follow-up questions or further discussions anyone viewing this webinar would like to have. Without further ado, let us transition into the city of Worcester. Now this is a traditional gravity-fed drinking water facility in Worcester, Massachusetts. It is a roughly 50 MGD facility with 8 gravity-fed filters that are using 24-inch butterfly valves to control and regulate the flow of water through their filtration system. And this is a picture of what the existing electromechanical actuator looked like on this filter effluent valve around 2011, before REXA did any work in the city of Worcester. The city of Worcester had always felt that they had some control issues in their filter system. And what they had noticed here is what is evident in this screen here by the purple trends, where you are seeing this purple trend as shown here sort of hunting up and down around a target position. This was typical inside of the Worcester filtration plant, as is amongst many other filter plants within the United States, when using an electromechanical actuator to control a butterfly valve. An electromechanical actuator is limited in how accurate they can position, how tightly they can control. Generally, you will see only about 2% resolution to control signal advertised, maybe 1% in some models, and that is directly right out of the box brand new before gear wear begins to degrade that resolution even further. And typically with an electromechanical actuator, you're using a butterfly valve, which has a CV curve as shown here, showing different types of butterfly valve curves, and that is an equal percent curve as shown in this slide, where you were typically using a butterfly valve that was most likely oversized for the gravity-fed filter service that it is being used on, meaning that you're controlling at a bottom portion of the CV curve, which is a very difficult place to control with an inaccurate actuator, that actuator being an electromechanical actuator. And so the point of REXA and the benefits that REXA can offer is that REXA allows an end user the ability to control a butterfly valve disc close to the seat, where usually you have an uncontrollable portion of the valve stroke with an electromechanical actuator. And when you use an electromechanical actuator to try to control at that portion of the curve, what you see is this purple trend here, where an end user is having difficulty trying to get to an intermediate set point that the actuator is physically incapable of dialing into. And when you have this type of problem, what you will basically do is jostle the flow of water going through your filter media. So you are not getting your most efficient capture rate inside of your filter. Since Worcester recognized this problem, in addition to other problems, which were reliability with the existing electric actuators, here showing you the internals of this electric actuator where they had lots of board problems, limit switch issues, and general maintenance failures due to gear wear over time, the city of Worcester decided to try a REXA actuator out, given that we advertise much tighter control on a magnitude of 0.05% resolution for deadband accuracy, how tightly we can follow a control signal. We advertise that by simply retrofitting an electric actuator on a filter effluent valve in most drinking water filter facilities, that we are confident we can prove a demonstrative performance benefit. And so what the city of Worcester, Massachusetts did back around 2012 is they gave us an opportunity by giving us a purchase order that was conditional. They gave us a purchase order for the amount that a Rexa would normally cost in this filter effluent valve, and the stipulation was that they had a certain period of time to try out the Rexa. At the end of that period of time, if they did not feel that Rexa performed well enough to demonstrate a performance improvement in the filter, we were willing to take back the Rexa at no charge. But if they felt that they saw a performance improvement, we were going to invoice them on terms that were favorable for them in their coming budget cycle. And so here you see the filter effluent valve that Rexa retrofit, and we will get into some more descriptive pictures later, and notice that it was plugged in with an extension cord because Rexa is a very low power, efficient energy consumption device. It only takes 115 VAC on just about all filter effluent or backwash valve installations. And so the plant, not sure how much of a demonstration for performance benefit we would show, simply plugged the Rexa in with an extension cord to an existing outlet because they weren't even sure if they were going to keep it. Well then, after the installation, they started noticing some performance benefits. And before we get to those, here is a quick slide showing what a typical Rexa installation might look like on a filter effluent valve. Rexa comes as the muscle, which is the actuator on the valve, and the brains, which is the separate control enclosure, only connected by some electrical cables. And so this is what just about every typical Rexa installation will look like on a filter effluent valve. You bring your power and your control signal to the control enclosure, and Rexa provides the equipment and handles all the rest of the connections. After the installation of Rexa on the filter effluent valve, the city of Worcester noted some very interesting improvements. When they first installed Rexa on the filter effluent valve, there was an immediate difference recorded in the trends for their filter effluent control valves. Rexa was giving them much tighter control versus the old electric actuators, which would normally hunt around. And the difference in the trends is demonstrated here. This is a screenshot of their 8 filters and their turbidity readings before Rexa, going back to around 2011. What you notice here are tremendous turbidity spikes during startup of the filters, spiking upwards close to 0.3 or at 0.3 on turbidity, and then taking some time to come down off of that backwash spike. And then you'll also notice some unevenness during steady state operation of the filters. Here are some of your filter turbidity readings shown in each of these trends. This is the after trend with the Rexa. The first immediate takeaway was that the turbidity spikes after backwashing were much less than they were before. Going back and forth here, they were spiking around 0.3. Now the Rexas were spiking on average around 0.1 on turbidity. And they were settling out a lot quicker after the backwash cycle, coming back down to steady state operation. And one of the other takeaways was that the average turbidity readings from before Rexa to after Rexa were significantly lower. So there was a demonstrative improvement in both turbidity spikes and average turbidity readings simply by changing out the actuators. In the past, with the previous electric actuators, the filter effluent valves would spike immediately open after the backwash because the electric actuators were very inaccurate, and the city of Worcester simply tolerated these spikes. But once they saw the improvement of Rexa in these trends, they were inspired to improve the control logics within the plant. Now that they had confidence in the positioning capabilities of Rexa, Worcester could now set their filter effluent valves to open to only about 25% after a backwash, approximating normal filter flow. As a result, instead of the huge turbidity spikes that Worcester would experience when the filters came back online, up to around 0.3 as mentioned before, Worcester now saw a significant reduction in turbidity down to about 0.1, along with a reduction in the filter to waste time as well. In addition, all of the chemical feeds in the Worcester plant were based off of flows, and so by tightening up the filter effluent flow, they were also tightening up the chemical dosing, which resulted in dollars saved by the City of Worcester on chemical dosing. So overall, there was a tremendous performance improvement that the City of Worcester felt just by retrofitting their existing actuators, which led them to retrofit the remaining 7 filter effluent valves with Rexer actuators, so that now all 8 filters within the City of Worcester, including the backwash valve, were retrofit with Rexa as the result of one trial unit. So, as a result of that, we then use the City of Worcester as a reference for use in the City of Elgin. And the plant manager for the City of Worcester, who anyone listening is welcome to be referenced to on behalf of Rexa, wrote an email to the City of Elgin detailing all of these performance benefits and also talking about how our backwash valve actuator that was now used helped them improve the swings that they were experiencing before with their existing electric actuators. Their backwash valve actuator was much more precise than the previous electric actuator with Rexa, and the backwash flow quickly went to the low wash rate as opposed to before when they had wild swings from the old electric actuator. Having the backwash flow do exactly what they wanted also allowed them to better optimize their backwash sequencing, improving efficiency. This reference that City of Worcester gave to Elgin allowed the City of Elgin to start exploring doing a similar trial unit here in their filter gallery, where they had existing electric actuators on a lot older American Darling valves, 18-inch butterfly valves, that they felt, in addition to being old and maintenance intensive, were also not controlling their filters as accurately and efficiently as they would like. Here you'll see a shot of one of the existing electric actuators and all the grease that would commonly leak out of this electric actuator on the ground, so much so that the plant would regularly in the past put catch pads underneath the electric actuators that they eventually gave up on. Rexer did a similar trial retrofit for the City of Elgin, as shown here in this slide, replacing one of the existing electric actuators. And then we also were told of some demonstrative benefits in the efficiency of the filter. This is a trend here showing 2 stories, showing turbidity versus time. The first thing you will notice is that after a backwash, as shown and outlined here with the cursor, typically the electric actuators in this trend line, which is of filter 1, would have a large turbidity spike that would take a long time to recover. Essentially, as shown in this time graph, it was a 4-hour event from when they backwashed to when the filter would recover to get back to normal turbidity that they would expect. It would take about an hour for backwash and about a 3-hour period for the turbidity to return to normal. And in fact, you can even see some turbidity spikes in the other filters that were caused by that one big turbidity event caused by backwashing one of the filters. After Rexa, as shown in this slide, there was much less turbidity effects, and they were taking only about an hour to do a backwash and recover to their normal turbidity readings versus the long recovery period that they experienced before. So the fact that Rexa was able to improve their control was demonstrated by the reduction in elimination of the long recovery from a high turbidity spike after a backwash. And this slide also shows that once Rexa was retrofit to filter 4, they had an event where they completely drained and refilled the filter for another reason. It wasn't a backwash. And you can see that while there was a high turbidity spike at that event, the recovery to get back was very, very fast. And so Rexa performed, the performance of Rexa was demonstrated out here by the fact that it had a quick recovery in getting turbidity back to where it needed to be after a backwash. And that has led the city of Elgin to move forward with looking to use Rexa on more filter effluent valves and other applications in their plant. Both of these references, Elgin and Worcester, as well as other ones we are about to show here, are more than willing to talk to any prospective customers or consulting engineers who are considering Rexa as a reason to be used on a pending or existing project to help improve control of the filters and ensure proper efficiency. In addition to our control value messages, we also have additional value benefits that we bring to customers. This is a shot from the Milwaukee Water Works, which is the Linwood drinking water facility, which is one of 32 Rexa actuators that were installed in that facility back in 2004 as part of major upgrades that were done to prevent any events from occurring, such as the crypto outbreak that happened in Milwaukee back long ago. And the story in this facility is that all 32 Rexa actuators on the filter effluent valves have had a flawless operation on this modulating service since 2004. That is what Rexa typically expects from an actuator on this type of service, is a minimal average maintenance-free cycle of about 10 years of service without ever needing to be touched. Every Rexa on a filter effluent or backwash valve service will come with a full 5-year product warranty out of the box, demonstrating how confident we are in the ability of Rexa to perform for such a long time without burdening the maintenance staff or budgets for longer periods than plants are used to. This is another example of an installation here from Johnson County out in Missouri at the Hanson water treatment plant, where 4 Rexas were installed on modulating filter effluent valves back in 1996. And all of them performed flawlessly for 18 years without ever being touched, until about a winter ago, where this particular unit required 4 hours of downtime and a $200 or $300 rebuild kit. That was the first amount of time and dollars for these 4 actuators that were spent in 18 years of service, which is one of the many reasons why Johnson County has standardized on Rexa throughout their drinking water operation, with somewhere between 50 and 75 Rexas installed in that facility at last count. Most customers, once they start installing Rexa to solve a headache, will standardize on Rexa for all critical applications, valve or gate applications within their drinking water operation to eliminate headaches, cost of ownership, and downtime. So here are some recent slides showing some installations that Rexa has done. This particular installation on the East Coast shows how a poor control signal inside of this plant SCADA system was causing a Rexa to do 2.5 million position changes to hunt over a 1.5 year period of time, which is the equivalent of about a 20 to 25 year duty cycle in a 1.5 years, because the power wires were wrapped in the same conduit as the control signal wires, and the Rexa was picking up induced noise on the control signal and interpreting them as control signal changes. But the Rexa, because it is so robust and able to withstand very difficult duty cycles, was able to operate flawlessly, and still, about 7 years later, continues to operate on these filter effluent valves despite withstanding such high duty cycles because of the design capabilities of what Rexa was built to handle. So we do a lot of filter effluent valves and a lot of backwash valves. Here in this particular plant, there are 16 filters in the background, all of which are tied to this common backwash valve shown overhead, controlled by a Rexa. If this Rexa fails to perform for any reason at all, it will shut down all 16 of the filters attached to this line for a period of time until the Rexa is back online and able to backwash, depending on the backwash frequency of this plant. There are 4 of these Rexas controlling 64 filters in this particular plant, with a flawless track record over the last 10 years. We also have the capability to offer a fail-safe. Here is shown a Rexa that was retrofit on a backwash valve to provide a mechanical fail-safe on this backwash line, in case a power outage occurred, this Rexa will automatically close this valve in a controlled manner. Finally, here is a design capability that Rexa also can offer, showing a backwash valve we did, where the valve was located about 20 to 30 feet above ground and required catwalks and staging to get access to. Rexa is able to separate two of its components, putting the cylinder that controls the motion of the valve up in the air and remote mounting our power module next to our control enclosure, so that if an end user has a shutdown or an electrical issue for any reason and still needs to manually move our actuator, here they can do so using our manual override and a cordless drill. This allows end user accessibility to the Rexa at all times and eliminates the need for setting up staging, ladders, fall hazard equipment, etc. that can become burdensome and time-consuming to plant maintenance staffs. We are able to design custom solutions that make things very end-user friendly with this product. So in closing, with this presentation and webinar here today, we wanted to point out the main things that Rexa can do potentially for any drinking water operation with a traditional filtration system. And granted, every plant is different, and we're not advertising that we can do this for everybody, but in our history, when given an opportunity, we have shown a remarkable record to yield performance improvements, and these benefits, as shown here, by retrofits or with consulting engineers on new project construction. And so in either case, these are the types of benefits, improvements, and value messages that Rexa, over the years, and more so now with our targeted approach to this application, have been proving out to end users for drinking water filter operation. And we would be happy to discuss any of these benefits with you as a potential customer or you as a consulting engineer for any retrofits of existing plants or any new project construction where the control, efficiency, reliability, low maintenance, and end-user friendly benefits demonstrated here by Rexa would prove to be worth it for both a consulting engineer in design or an end user in the field. Here again is my full contact information. We would welcome any interest to further discussion, have further discussions about this type of work, to take a close look at your potential opportunities, or to reference you to any of the accounts that we show you here today. Our best salespeople for Rexa are the end users that use this product to solve control or reliability headaches that they experience in the field. Our end users are always willing to talk to potential customers and tell them their stories, seeing that they sit in similar shoes as any of our potential customers. And so please feel free to reach out to us anytime, and we thank you for your time here today. And thank you again, and we look forward to hearing from you.